Hello students, as we discussed about atoms, it is clear that atom is the smallest particle of an element. Because these are smaller, it is not easy to find out the mass of atom. So let us discuss atomic mass and molecular mass. If I ask you to find out the mass of a cricket ball, it will be quite easier for you. You need to keep the cricket ball on the weighing machine and find out the mass. But the same if I ask you to find out the mass of a single atom, do you think that it is easy for you? Definitely not, because the size of the atom was extremely small. Because of this reason only, it cannot be determined even with the help of most sensitive balance. For example, the absolute mass of hydrogen atom is found to be 1.67 into 10 raised to power minus 24 gram. You can imagine 10 raised to power minus 24 gram. It's such an extremely small number, which is very inconvenient for calculation. So this difficulty was overcome by expressing the atomic masses as relative masses. Let us discuss what is relative masses. Relative mass. Let us discuss what is this relative mass. For better understanding this concept, we are keeping 3 balls on the weighing machine. It is not an atom. Consider this as a ball. The ball X, ball Y and ball Z. Let the mass of X I am keeping as 1. I am representing the mass of X let as 1. So it is observed that the mass of Y is 2 times the mass of X. So at the time, if X I am keeping as the mass is taken as 1, so what will be the mass of Y? The mass of Y is taken as 2. Similarly, the Z ball, let the mass of Z is equal to the 5 times the mass of first X ball. So at the time, what will be the mass of Z can be represented? It can be represented as 5. That means here the mass of X is represented as 1. This is 2. This is 5. Here 1, 2, 5 are not the actual mass. These are the relative mass. That means Y and Z their masses are relating with the mass of X. As the mass of Y is 2 times the mass of X. Therefore, the relative mass of Y is taken as 2. Similarly, the mass of Z is found to be 5 times the mass of X. Therefore, the relative mass of Z is taken as 5. So, as I told you, 1, 2, 5 is not the real mass. It is the relative mass. We can say comparative mass. It is compared with particular ball here. So that is a relative, or we can say comparative mass. Let us take example. Let us take 2 atoms, hydrogen atom and oxygen atom. So the hydrogen atom is taken as a reference atom here. Because of the smallest in size, it is taken as reference. So let the mass of this is taken as 1. And it is observed that the mass of the oxygen is 16 times more than the mass of hydrogen. So the relative mass of oxygen is taken as 16. So the relative mass is not the actual mass. It is the this mass is comparing with the mass of a reference atom. So that is, it is called as relative atomic mass. In this case, hydrogen atom is selected as a standard reference because of its lightest of all the known atoms. So at first, hydrogen is selected as a standard reference. That means hydrogen is taken as 1 and other elements are taken, other atoms are taken with reference to this, because of the smallest size atom is hydrogen. But in 1961, the International Union of the Chemists selected C12 isotope as a standard for comparing the atomic and molecular mass of element and compound. So earlier, which one is taken as a reference? Hydrogen is taken as reference. But later on, after 1961, C12 isotope is taken as for reference. C12 isotope, let us discuss what is C12 isotope. C means the carbon atom, and here 12 represent the atomic mass. Atomic mass means here it is the number of proton plus neutron is given as the number 12. So C12 means it have the total number of proton and neutron is equal to 12. So there are 3 types of isotopes of carbon are there. From this, one of the isotope is C12. So C12 isotope is selected as a reference or the standard for finding out the relative mass of other elements, atoms of other elements. Mass spectrometer. The atomic mass can be determined on an instrument called mass spectrometer by comparing the mass of an atom with the mass of a particular atom chosen as a standard. As C12, that is carbon 12 isotope, is taken as standard. So by the use of this spectrometer called as mass spectrometer, we can find out the mass of another atom by comparing with the mass of carbon 12 atom, which is taken as standard. So this scale of relative mass of atom is called atomic mass unit cell. In short, we can say AMU. Let us define AMU. AMU, that is atomic mass unit. One atomic mass unit is defined as the quantity of mass equal to 1/12 of the mass of an atom of C12 isotope. That means 1 AMU is equal to 1/12 of the mass of the C12 isotope. A new symbol is given, that is unified mass, in the place of AMU. Unified mass unit, which is also called as atomic mass unit. It is 1/12 of the mass of carbon 12 atom. Let us distinguish between atomic mass and the nuclear mass. Atomic mass is the mass of an atom complete with its electron. But the mass which you have calculated till last year, the atomic mass, that is you are finding out the sum of number of neutron and proton. So in that we are not considering the mass of an electron. So the mass of an atom with the complete electron, proton, neutron is the atomic mass, and the mass of only the proton and neutron is called as nuclear mass. Since the mass of an electron is very small in compared to other, so there will be a slight difference in these value. So 1 AMU, when we find out 1/12 of the mass of C12 isotope, will be getting value, that is 1.66 0.056 into 10 raised to power minus 24 gram. Let us find out the mass of hydrogen atom in 1 AMU. So what is the mass of a hydrogen atom? It is equal to 1.6736 into 10 raised to power minus 24 gram. So mass of a hydrogen atom in AMU can be found out by taking the ratio of mass of an hydrogen atom, that is this, divided by 1 AMU. So when we divide this one, we'll be getting 1.008 AMU, and which can be rounded off into 1. That's why you are taking the atomic mass of a hydrogen atom as 1. From this it is clear that the atomic mass is taken in a unit, that is atomic mass unit, and it is also taken in the unit, that is unified scale or atomic mass unit scale. From this, when we find out the atomic mass of hydrogen, we'll be getting the value 1.008 U, which is approximately taken as 1 U. Atomic mass of oxygen, when we find it out by this way, we'll be getting 15.9994 U. That is approximately taken as 16 U. That's why whenever you are writing an atomic mass for hydrogen, you are keeping as 1, and atomic mass of oxygen keeping as 16. But in the case of element which have more than one isotopes, average atomic mass of that element can be computed. Let us take one example. In the case of carbon, there are 3 isotopes of carbon. These are C12, C13, C14. The average relative mass depends upon the isotopic composition of that particular element. So, the best way to define atomic mass of these element is to determine the atomic mass of each isotope separately and then combine them in the ratio of their proportions of occurrence. This is called average atomic mass. So as shown in the figure, we can find out the atomic mass, that is average atomic mass for isotope of carbon. So from this we conclude that we have discussed about the atomic mass, a new scale which is called as atomic mass unit scale, which is also called as unified scale, and we discussed why the C12 is taken as a reference, and the average atomic mass can be computed, which we have discussed here. So the details of the next concept will be discussed in the next video. Thank you everyone.